I'm Hana Amir. I work at MMRI as a marine biologist and but coral reef researcher. I'm present in this work on behalf of my working group, composed of Bashir, Ilham, Simone, and Phillippa. And I'll be presenting on work that has been carried out evaluating the extinction risk of corals as part of the National Red List initiative. So, what is this initiative? It's an initiative by the Ministry of Environment, Climate Change, and Technology that obliges them to create a list of endangered species in the country. And this initiative has looked at various taxa, and corals are just one of them. And we had to bring in experts from all over the country to try and do this work. And this is why we have the Corals Working Group, composed of researchers from Six Senses Law, MARE, the Ministry of Environment, Climate Change and Technology, MMRI, and IUCN, and so on and so forth. So we're a big group working together. Small group, but big. So what are the challenges as part of, what were the challenges when we started doing this work? Well, for one, stony corals in the Maldives were really, really diverse. There's at least 248 species from 57 genera. And the species richness posed a very big challenge in trying to figure out what to prioritize. So what do we evaluate first out of these 248 species? Do we evaluate things that we had more data for? Do we evaluate the things that we think we are going to lose? How do we decide this? Making this even more of a challenge is the fact that, well, we had data constraints. Nationwide, there's nearly non-existent species data, whether it be from Pasenkawa's reports or whatever, there's nearly non-existent species data. But we do have generic data, but the issue with the generic data is that it's also spatially and temporally limited to do this kind of assessment. Further making this even more complicated is the fact that there were taxonomic changes to the corals. So entire genera of corals split apart, others became one group. So it was a confusing time for all of us. But these are challenges that are also faced by the global group that's doing the red list assessment for IUCN. So the international IUCN red list. So they're also facing these challenges. So what did we do? So for one thing, we created distribution maps using genera. So we looked at percent cover of genera, presence, reports, observations people have had, and we made distribution maps. These generic maps, we then distilled it down to try to distill it down to species by looking at the depth ranges. So we took bathymetric data, collated it all together to try and get a species map. So we at least know where this species might be found in the country. So this is an example of one of these distribution maps. So for the acropora species, in blue, if you're able to see it, those are where we have data reports of whatever kind, confirmed occurrences of acropora, while the red is an estimated distribution of where it's found in the country. So it's pretty widely distributed as one would expect. So next, we try to figure out how much of a species or genera was there. And for this, we had to look at 10-year long-term means. We chose 10 years because 10 years is the estimated general length of a coral as part of the IUCN Red List. And there are limitations in the data as well. So taking a 10-year mean provided us a way of not underestimating or overestimating how much of a coral is found in a place, which is important when you're trying to evaluate their extinction risk. Afterwards, we try to figure out how vulnerable a species is. So calculating species vulnerability modifiers based on the species characteristics. So this took things like how resilient, how susceptible, or how well it would recover from a stressor like climate change stresses or even anthropogenic stresses. A higher score means that is at higher risk, a lower score, lower risk. This After that, we try to calculate how much of a risk to climate change impacts there are. For this, we had to look at annual severe bleaching onsets calculated by the United Nations Environmental Program. And annual severe bleaching is defined as the date at which a coral reef will likely experience severe bleaching conditions annually. And after this date is the year at which it's very unlikely for these populations to recover. So based on recent climate change reports, CO2 projections, and all these very depressing reports, we decided to go on a precautionary route and say that corals are unlikely to be able to change to climate change at the rate at it's going. So a 0-degree adaptation. And this is what this risk looks like across the country. So as you can see, the year at which annual severe bleaching onset is different from region to region, and we had to take an average for each species based on where it is found. So the distribution map and this map was sort of collated together to calculate the average onset year for each genera or each species. So all of this contributes to try and figure out how it contributes to our evaluation. So we had to take two approaches here based on the IUCN Red List method. So the first approach, we looked at future population reduction. So we had to look at the risk of decline from 2022 to 2052. These dates are specifically because it's 3-generation length of a coral. So one thing to keep in mind, we had to keep in mind as we did these evaluations as well, is that this ASB mainly affected the shallow, so 0 to 30-meter depth. And we had to calculate which proportion of a population is affected by this event. So we had to look at the depth range of each species, figure out within those 30 meters how much of their population is being affected, and through that evaluate how much of risk it is. And this is then paired with the vulnerability score to either increase their risk or decrease the extinction risk. The second method, but the one we didn't use too much because of the data constraints we had, is looking at past population declines. So we had to use generic data as a proxy here, but we looked at declines from 2015 to 2022 and simultaneously paired them with vulnerability scores to try and figure out the extinction risk. So this directly maps onto the IUCN methods I mentioned before. So are they critically endangered, or vulnerable? So if a population between 30 and 50% is affected, it's vulnerable. If a population between 50 and 70% is affected, it's endangered. And if a population between 80 and 90% or higher is affected, it's critically endangered. Of these categories, of these IUCN categories, the main one we looked at is something called A3, so population reduction projected, inferred, or suspected to be met in the future, and then specifically looked at the subcategory C, a decline in area of occupancy, extent of occurrence, and or habitat quality. So we are saying that the quality of their habitat would be declining because of this onset of annual severe bleaching events, either raising or lowering their extinction risk. So what have we been able to do so far? We've completed 38 assessments of coral species, and while that might not seem like a lot, it is 19 genera representing about 33% of all genera listed within the Maldives, and 15% of all coral species listed within the Maldives. So that's a fair amount of work, I think. So what were the results we got? So in terms of critically endangered, we evaluated 22 species to be critically endangered, 8 species to be endangered, 5 species to be vulnerable, and 3 species to be near threatened. I'll go through an example of each category, just to give you an idea of how they ended up being evaluated. So one of the examples for a critically endangered species is Acropora hemprici, so a type of Acropora. In the global IUCN Red List, this is a vulnerable species, and there are distribution records of the species, of the genera, across the nation. But its depth range is from 3 to 15 meters. So its entirety of its depth range is affected by ASB in a projected timeline. Furthermore, its vulnerability score is a 3. So it's really susceptible to bleaching. It has basically no resilience. It doesn't recover all that well. And on top of it all, it's very, very susceptible to anthropogenic impacts like sedimentation and with low recovery. So it has a pretty high vulnerability score. So we expect its population to get reduced by 10 to 90%. Hence, it's a critically endangered species in terms of a national evaluation. Moving on to an endangered category, we looked at an example is the Galaxia fascicularis. In the IUCN Global Red List, it's a near threatened species. And again, this species does have records nationwide, and its depth range is from 1 to 15 meters. So this is sounding a lot like the Acropora hempricki, I'm sure you'd notice. But its vulnerability score is a 1. And this is because it's very resilient to bleaching, low susceptibility, and it's pretty good at recovering. Moreover, it's pretty resilient to anthropogenic impacts as well. So it recovers well, it's resilient, so its vulnerability score is a 1, and we expect its population declines won't be as high as something like Acropora hempricki. Hence, we say this is an endangered species instead. Looking at a vulnerability species, we have Phillippa vercosa. In IUCN, the international list, it's the least concerned species. This distribution is also nationwide, but it has a higher depth range. So only a proportion of its population would be affected by the 0 to 30 meter ASB onset. Its vulnerability score is also moderate because it's moderately susceptible to bleaching. It has a moderate recovery rate, and it's moderately susceptible to anthropogenic impacts like sedimentation as well. So we don't expect its reduction in population to be quite as high either. Further, looking at the last category, near threatened, we have Tubastia micranthus. It's not evaluated yet by the International Red List, but we are saying it's a near threatened species. Currently, we have only confirmed from central atolls. We suspect it might be wider, but confirmed occurrences are only from the central atolls. It has a really wide depth range from 5 to 15 meters, and on top of that, it's a zooxanthellid. So it doesn't rely only on the zooxanthellid for its food, so it's not as vulnerable. Further, it's not as susceptible to bleaching, and it's pretty good to recover if it does bleach. So it's near threatened at 20 to 30% projected decrease in population. So there's some variability within the genus as well. Some genus are more vulnerable than others, but there's intra-genus variability as well. So if you look at the Acroporas, most of it is coming as critically endangered, but there are species that are coming as just endangered as well. Phillippa is a more resilient genus, but it also has variations in their evaluation. So some are endangered, but others are vulnerable. So evaluating the extinction risk of the monumental stars that seemed near impossible when it started out, but with some combined efforts and some creativity, we've been able to carry out these evaluations. There is so much more we need to do in terms of understanding our coral population, specifically at species level, but it's something I expect we'll be able to do together. So concluding off, I thank all the organizers for letting me present this, as well as my working group for their support. Specifically, I'd like to mention Shafi and James for their guidance throughout these assessments.